Hey, what's up, guys? Welcome to this video, and I'm going to be talking to you about capacitors. And a capacitor is one of the most important components in electronics, and it's really known for its ability to store and release electrical energy. And this function actually makes it invaluable for a wide range of applications, some things like power supply systems, the signal processing, and a lot of applications. And it's a really simple device, right? The capacitor is a simple device. And it really has two conductive plates separated by insulating material we call it dielectric. And depending on the type of dielectric material you use, the capacitors have certain properties and they are used for certain applications. And one of the properties that this dielectric kind of influences is whether the capacitor is polarized or non-polarized. Now, when you say polarized, it means that the capacitor will only work properly if we put it a certain way in our circuit. So a polarized capacitor kind of expects one leg to be connected to the positive end and the other leg to be connected to the negative end. The non-polarized capacitors don't really care about that um orientation and how we connect it. Now, I could kind of show you some of the types of capacitors we have here. So the first one I actually want to show you is the classic. It's called an electrolytic capacitor, right? And it looks like this. You're probably accustomed with this. And for the polarized part, you see the negative. The leg actually has the negative symbol on it, and you see the positive side has nothing on it, right? So once you're looking for this kind of you know um black and white stripe with the negative symbol, and also the legs, you'll notice that the negative legs is always shorter than the positive one. The positive one is really long, right? Um, you also look at I want to talk about the capacity. So you see, mark on it, you have 68 UF. This F is actually stands for farads, and farads is a really big quantity, and it kind of measures how much how much energy the capacitor can kind of store, the capacitance value. And it's a 68, and it also has a voltage on it. And this voltage, is the maximum voltage that the capacitor could work. Work in. We call like the working voltage. Sometimes you see um it actually have WV, for working voltage written on it. So we also have these ceramic capacitors, and we'll be using these a lot when we start doing microcontroller stuff because these are used for different purposes, what they call the coupling, and we'll actually talk about the coupling later on in the series. But you'll notice that these have a marking on them. You see like 104. And this actually translates to, 10 by 10 to the power of 4. And a lot of different tables you could look at, to kind of, read the value of these capacitors. There are some that you will be confirmed like 104, is zero point 0.1 microfarads or 100 nanofarads. You also have, down to the picofarad range, which you can use for crystal oscillators and stuff like that. But generally, these are types you'll use. Now, um, sometimes you can encounter capacitors that look like this, right? These are surface mount ones that actually have it soldered onto these two wires here, so I will lose them. But these tiny ones really, they like to play hide and seek, right? You have to be careful with them. And they don't really have any marking. So the way you kind of measure them. This one is actually a 10 microfarad one, but the value changes, depends on what is specified for the circuit. And lastly, I also want to show you these tantalum capacitors. I kind of use them with my PIC 32 stuff because of the equivalence of resistor properties. We need to not too much about that now because usually, as a beginner, the data sheet will kind of usually tell you what type of capacitor it expects. And typically, they kind of safe with ceramic and, tantalum for some applications. And these actually will have, these are also polarized, even though they don't look like that. The camera not showing in focus, but you'll actually see, I'm not getting any focus, but it's actually a little positive marking right there on it. You'll see like a plus sign. And I know that indicates the positive one. And this one, if you cut the leg, so they're the same size. So you can't really rely on the leg size right there. You have to kind of pay attention to the device. Now we could stay only talking about capacitors, but I kind of want to demonstrate them. And so this is surface mount. There's also surface mount tantalum capacitors that kind of look like this. Right? You don't really use these as much, but you do come across them from time to time in certain like power applications and things like that. So the circuit we want to use is just to show the capacitor storage capability. And what I have here is we have this circuit, right? So we have the circuit here, and if I actually just remove the negative line, you see it goes off instantly, right? So remove the negative, instant off, right? And what we could do is we could actually put a capacitor in the circuit. So we start small. Let's say we start at like 100 microfarad one. So we have the negative side. Make sure the negative side is on the negative, right? And we put the positive side on the positive. And now when we remove it, you see it has a slight fade. So look at that, and it actually fades off, right? To get a little more that effect a little more pronounced, we could actually put a 1000 microfarad capacitor here, and on the positive supply, we let's drop him here, right? And when you remove him, wow, look at that, how slow that fade is. So you kind of seeing this property in action. You're seeing the really, really slow fade, right? Because the capacitor is actually supplying um power even after you remove it. Now the smaller one, so let's see the 10. I promise this is a capacitor too, so this is actually the 10 microfarad ceramic. When you remove it, and the fade is you know almost instantaneous. There's a slight delay, really, really slight delay. And if we put something like our the 0.1 microfarad one, almost no difference, right? It's almost a kind of instant off. And that's because, like I say, capacitors, you don't only use them for the storage purpose. There are other purposes, and I also want to mention something called supercaps. And supercaps kind of have their capacitance in farads. The thing is that supercapacitors, they tend to usually have a smaller voltage. And in fact, I think I could show you one. So this one here is actually a 1 farad. I don't think I get it in focus, are we? Yeah, it's slightly getting in focus. This is actually a 1 farad capacitor. It stores an entire farad. But the voltage is only rated for 2.7 I'm not getting. Maybe if I adjust the lighting, let's see. Some lighting adjustment, that will help. That'll help a lot. Right, you kind of seeing it there now. So it's actually 2.7 volts at 1 farad. And if you notice this compared to say like the 68 microfarad one that's 100 volts, you see that the supercapacitors, even though they have a larger storage capacity, um they tend to have really low working voltages, like 2.7 volts, 3 volts, 5 volts, like really small. 2.7 is kind of where they usually work at. And it's physics, right? You can't beat physics. You trade off a larger capacitance for lower working voltages. So that's the introduction to capacitors, guys. For embedded systems development, that's kind of what you need to know. You need to know, they could kind of help store current to kind of stabilize, store voltage to kind of stabilize, circuits, kind of help with voltage fluctuations and stuff. And for the coupling, smaller values for the coupling. And that's typically what you use capacitors for, unless you kind of get into specific power applications. So that's it, guys. Thanks for watching this video, and this has been really nice. In the next series, the next video, I think I'll be covering inductors with you all a lot. So thanks for watching, guys.